Day. Good morning, good afternoon, or good evening, depending on where you are in the world, and welcome to today's SecurityBoulevard.com webinar, brought to you by TechStrong and SciCode. My name is Cody J. Brown, and I'm the host of TechStrong Learning. We have an exciting panel ahead, but before we begin, I have just a few housekeeping notes. First, today's event is being recorded, so if you miss any of the presentation or you'd like to share it with a friend, that will be made available to you after the webinar concludes today. On the right side of your screen, you'll see a couple tabs. The first one being chat. This is where you can engage with one another and engage with us. The Q&A tab right next to the chat tab is where we want you to send in questions. We have time at the end of the webinar to address as many questions as you can send in, so be sure to send them in early. We have a couple polls that will be flashed up throughout today's webinar, so keep an eye out for those as your participation is highly desired. And finally, at the end of the webinar, we will have a giveaway for 4 $25 Amazon gift cards, so stick around. On to our topic today. It is Securing Infrastructure as Code from Tampering and Misconfigurations. And I'm joined today by Amnon Evan-Zohar, Director of Product Management at SciCode, and Orion Cassetto, Senior Director of Product Marketing at SciCode. And it is my pleasure at this point to turn the floor over to them to get us started. Thank you so much for being with us, both of you.
Thank you much for the introduction. So I'll go ahead and kick things off. Today, our agenda, we've got quite a lot. We'll start with an overview of the state of infrastructure as code. We'll talk a bit about why IAC, or infrastructure as code, security matters. We'll go through some best practices and important considerations when you're looking to create a program to secure your infrastructure as code. Then we'll go over a demo of the SciCode platform, and then also we'll do some Q&A. Also, we've got a couple of poll questions that we'll do as we start to move through this. So, if you have questions that pop up ahead of time, feel free to send them into the chat box. We may have an opportunity before the end of the call to get to some of those questions while we're waiting for people to fill out the poll. So with that, I want to kick things off with our first poll. So first off, I'm going to open up that poll, and then we will see what you guys think. So today's first poll question is, have you implemented infrastructure as code in your organization? The options are, we haven't implemented IAC and it is not on our 12-month plan. Number 2 is we're looking into infrastructure as code. Number 3 is we've started, or we have not started, but it is on our 12-month plan. Number 4, we're in the process. And number 5 is we currently use infrastructure as code. So if you guys can go ahead and start answering that, we'll go ahead and see what you guys think. We'll give it another 30 or 40 seconds, but this is a perfect opportunity. In the future, we have a couple of more polls. So during this gap, we can answer some of your questions. So we'll give it another 20 seconds or so. All right. Looks like I launched the wrong poll, so sorry about that, but we'll come back to this one. The poll actually was quite interesting, but we'll carry forward. So we'll come back to that one. All right. So we'll start things by talking about infrastructure as code and where we are and how we got here. So, traditionally, infrastructure, when your application development teams needed infrastructure to run their applications and programs, essentially they needed to procure it by way of an IT ticket. So, you go into a ticketing system, you tell IT, this is what I need. That would be procured for you, and then rack and stacked. And then essentially all of the maintenance and updates and capacity enhancements was all handled in the same way by IT. Now, this worked more or less okay as long as you had kind of long-lived systems that didn't change that often, but it was really not very flexible, and it didn't really match with, kind of modern application development. So then, that kind of gave rise to cloud infrastructure. So once you had cloud providers in the scene, essentially you could, scale up and down infrastructure by just, spinning it up in these providers without the need to involve IT. And this could be done, in minutes instead of hours or days. The problem here was that as you started to scale up and down to meet capacity needs, so to scale up for capacity, to scale down to save on costs, essentially you still needed to do this, manually, maybe by way of a script, but still more or less manually. And so what people essentially started to do was write down and codify the steps that were needed to increase capacity and to increase the provisioning or to automate the provisioning of this infrastructure. and that gave rise to infrastructure as code. So that's essentially how we got here. Amnon, you want to dig a little deeper?
Yeah, can you hear me well?
Yep.
Awesome. So yeah, in continuous to what Orion mentioned, let's talk a bit about what is infrastructure as code. So infrastructure as code is essentially the technology and processes used to manage and provision infrastructure with code instead of manual processes. And this is done through using software development principles and practices. The idea is that your infrastructure is treated just like software, and then each one can actually write, test, and execute code in order to define, deploy, update, and destroy the infrastructure that is provisioned. We write code to manage our servers, databases, network logs, and so forth. And in continuous to what Ryan stated in the previous slide, when you want to make changes to your infrastructure, you make changes essentially to the code. This is basically the best practice in this industry. And then afterward, you can test it and then apply it in your production environment automatically. As such, first, it has replaced the act of racking physical servers in the data center. And secondly, it has allowed for building servers using software programming in the cloud. Infrastructure as code tools and processes allow engineers to quickly build and destroy servers and other infrastructure on the cloud platform using automation tools. If we'll go to the next slide, then we kind of gathered for you a short and very simple example of a basic deployment in AWS for one of the instances, for an EC2 instance, one of the the cloud assets running on Amazon Linux 32-bit AMI. And as you can see, by the way, this can be also implemented for Google Cloud, GCP, Azure, and Kubernetes. It's just based on different tools such as Terraform or YAML files. Using code like you see here in the slide allows us to ensure that the outcome, meaning the infrastructure provision, is always the same. And when we need to update it, we simply replace the infrastructure resource with the new updated one in the code itself. The ultimate result of this infrastructure as code is automation. And having our infrastructure provisioned using code allows us to automate an otherwise manual task. Back to you, Ryan.
Sure. So essentially, there are a number of infrastructure as code benefits. The first one is faster software delivery. So it allows you to speed up configuration and implementation of new computing infrastructure. It allows for quick provisioning of infrastructure for development, testing, production results in your and production results in your ability to deliver software much faster. Amnon, do you want to tell us a little bit about some of the other benefits we've got here?
Sure, we'll be happy to. So the second benefit is self-service. So as the infrastructure is defined as code, the entire process and deployment can be automated. It can be started by anyone, mostly in the DevOps team. Users of infrastructure get the resource they need and when they need that. The third benefit, as mentioned here, is reducing cost. It actually means that reducing the time and effort required to provision, and this is done, as mentioned earlier, through automation, which is much less than manual provision. When we're looking at the fourth benefit, which is version control, so essentially, traditionally changes to production systems were considered risky, but then change is inevitable, and we're probably experiencing that on a day-to-day or on a week-by-week. You may need a new database when you add a new feature. You may need to add new servers or structure or storage to the cluster. Infrastructure as code reduces the effort and risk of making these changes to the infrastructure. You can check in your source files in the version control, which means that you can track all the changes done and revert quickly to the previous one if something breaks. And the last and least benefit is consistency. So generally speaking, manual process results in mistakes, most of the times. Communication is hard. Manual infrastructure management will result in discrepancies. no matter how hard we will try. So infrastructure as code solves that problem by having the config files themselves be the single source of truth. That way, we guarantee the same configuration will be deployed over and over again without any discrepancy.
Awesome. Thanks, Amnon. All right, so we're going to shift gears in a second. We'll talk about what are the security implications of IAC. But before we do that, we're going to try polling again. So hopefully it will work. It's been a lot of technical difficulties today. But so poll number 2, I'm going to start it now. Hopefully it matches. So we'll give it a shot. Okay, poll number 2 should be open. It is, which tools are you using for infrastructure as code? So feel free to go ahead and vote now. You should see some options on your screen, and essentially you can use multiple tools. The options are AWS CloudFormation, Terraform, Ansible, Kubernetes, including YAML and JSON, and then Azure Resource Manager. So go ahead and vote, and we'll give all of you a little bit of time. Okay. Getting there. We'll give you another 20 seconds or so, but so far we've got the most of everybody's using Terraform. Number 2 is Kubernetes. Number 3 is AWS CloudFormation. Number 4 is Azure Resource Manager. So I'm going to go ahead and close this poll so you guys all get the results. There you go. All right, so we'll keep everything moving. So from here, we're going to shift gears and we'll talk a little bit about the security implications of infrastructure as code. So Amnon, back over to you.
Cool. Right. So we talked about a lot on the automation piece for infrastructure as code. And as mentioned here in the slide, infrastructure as code automates provisioning to boost the efficiency. However, it also amplifies mistakes. So as infrastructure as code adoption soars, it's becoming more important to understand the security risks and the complexities involved with it. Because infrastructure as code best practices are still being established, there are very few universally recognized resources and processes when it comes to infrastructure as code security. Essentially, and we mentioned that earlier, infrastructure as code is designed to make cloud provisioning simpler, faster, and predictable. But in order for teams to recognize those benefits, the same philosophy must be applied to how they approach cloud security. Infrastructure as code security is essentially the answer to cloud security in an infrastructure as code, forwarded or adopted environment. It's essentially the only way to get consistent, scalable, and immutable security. If we will not apply security at the infrastructure as code level, then misconfigurations are inevitable. They will just happen, and we hear that over and over again. And when clouds are orchestrated by inherently misconfigured code, they'll continue to be orchestrated and configured incorrectly in production over and over. So why infrastructure as code is important? Number 1 is identifying potential security and compliance gaps earlier reduce the risk. Proactively identifying and remediating misconfiguration in code enables security engineer teams to remediate issues before any infrastructure is created in production. Infrastructure as code security tests can be integrated early in the development processes, such as when writing code, committing in the pull request, code to the repository, or even prior to deploy. So that's reason number 1. Number 2 is that small infrastructure as code misconfigurations can become large runtime attack surfaces. What does it mean? It means that because these templates enable rapid, potentially high volume deployment of resources, and because infrastructure as code templates are often reused by different teams in your organization, then even a single line misconfiguration can have an enormous impact on many cloud resources at the same time. And most of the time you even don't get visibility to where actually this attack surface has been exposed. Third important level or reason is that be aware that, or we should be aware that some runtime misconfigurations cannot be fixed. So many resources such as Amazon RDS instances or Elastic Load Balancer volumes have configuration settings such as encryption that cannot be changed once an instance or volume is live, making this security even more important. Another item that we need to keep in mind is that securing infrastructure as code templates frees up our security team to focus on runtime issues. And we always hear all the time that these teams are always understaffed. So by fixing potential misconfiguration in the code itself, when things are easier to resolve, then security engineers have more capacity, more time to focus on identity and access management permissions or any other resources and out-of-band modifications that affect the security posture. And the last thing is that the development security fosters also a culture of security. So every person has an effect on your organization's security, and your security posture is only as strong as your weakest link. In the next slide, we will dive even in more details on how these use cases and considerations. So we can see here some numbers that actually emphasize what are the impact and predictions for these misconfigurations by numbers. So according to Gartner, more than 99%, which is unbelievable number of cloud breaches will have a root cause of customer misconfiguration or mistakes. In 2020, which was actually last year, 35% of organizations had a storage bucket exposed to the internet. Obviously, when you have such a bucket exposed, then it's publicly accessible, and the data that is stored in this bucket can be stolen or updated without our customers knowing that. And the last important fact is that roughly 50 billion records leaked just in the time of between 2018 and 2020 due to this misconfiguration. So as you can see here, the numbers kind of emphasized what we're trying to deliver here, the message, which is the importance of infrastructure as code security. We gave here some numbers of a survey that was done taking 200,000 infrastructure as code templates and kind of running them through some of the misconfiguration. We can see here that just by scanning these, it appears that almost 50% in these templates, the AWS S3 buckets did not have server-side encryption enabled, which is a very standard and required configuration in order to make sure that your bucket and the data that is stored is secured. More than 40% of CloudFormation config files have at least one insecure configuration, which is, again, almost more than 2/3 of these numbers. And the last and very important number to back up our claim is that almost 60% of cloud users configured S3 buckets don't have logging enabled. No logging enabled means that you will not be able to track and address issues that are happening in these buckets. All right, back to you.
Thanks. Now that we've talked a little bit about the problems with IAC security, let's talk about some of the challenges with actually securing it. So there's really three fundamental problems to securing infrastructure as code. The first one comes down to visibility. So like a lot of other kind of modern DevOps tools, essentially IAC is owned by engineering and DevOps. It is often used and the templates exist outside of security's visibility. So, security often doesn't even get the opportunity to look at these templates and definitions and to determine if they are secured or not. And so, essentially that provides is a blind spot. And ideally, security should have the ability to not only see these templates, but also to create and apply policies for your IAC so that it can be rolled out in a secure manner. The next issue is really about complexity. Fundamentally, developers are developers, they're engineers, they're not necessarily security professionals. And, it's a bit, security is a complicated thing, and it's a bit unfair or unrealistic to expect that, your average developer is going to be up to date on, the hundreds of potential security policies that might need to be implemented across multiple cloud providers. So it's really a big task. It can be a bit daunting. And to be fair, that's the job of us security professionals, not necessarily of the developers. The last point comes down to automation, and I think Amnon mentioned this a couple of times, but essentially the same capabilities that provide the efficiency and the scalability of the IAC approach are kind of double-edged, right? And a small mistake in a IAC template, like encryption is false or true, can scale up to be a very big problem when it comes out into production, because there's a one-to-many relationship between the template and the infrastructure that comes from it. Also, manual fixes that are done to production environments and infrastructure can reappear if they're not fixed at the IAC definition or the IAC template level, because essentially, you have that same problem. It exists in the template, and the next time that infrastructure is provisioned with that template, that problem is going to reappear. So, we feel these are the three fundamental problems that need to be solved. So essentially, we need to restore visibility to security teams. We need to involve developers in a way that is not complicated. And we need to use automation to our advantage as opposed to disadvantage. Okay, so we had a poll here. We have already launched it because of the mix-up from earlier. So I can see the answers, which is that... let's see if I can still pull that up. Close that poll. And so the answers from when we went through this earlier. So the question was, how do you identify security misconfigurations in your infrastructure as code? The top answer was periodic scanning of production environments after deployment. That was about 36% of everybody. The next answer was manual code scans, and that was 23%. From there, it was from investigations, so actually doing an incident investigation, and that's about 20%. And lastly was only 21% of people had an automated testing process that included IAC scanning as part of their continuous integration. So very interesting stuff. All right, so now that we've talked about, essentially what is infrastructure as code, we've talked about why this is an important problem and why it's a challenge. We're going to tell you a little bit about how to implement effective IAC security. So Amnon, back over to you to walk us through that.
Thank you. So, the results of the earlier poll makes a lot of sense, and we wanted to use this time to elaborate more on the different approaches in order to identify this infrastructure as code misconfiguration. So the first approach is what we call the misconfiguration scanning, which is the majority of you, mentioned in the poll. The developer of the infrastructure as code templates may use insecure default configuration and/or components with known vulnerabilities in the template or script that could pose essentially a threat to the entire environment. And so the most basic and apparently also the most common, at least from the attendees in this call, in this webinar, is a form of infrastructure as code security is actually be able to identify misconfigurations and security issues by scanning these templates. So scanning infrastructure as code essentially enables you to identify all the variables for which the proper settings are either missing or inaccurately set. It also involves checking templates, files, and modules, and also their variables, because this can be complicated, against well-known policies. Policy violation then occurs when proper settings are either missing on variables or the settings are incorrectly set. Because infrastructure as code is often cloud agnostic, then you may be dealing with hundreds of policies to check against. So the best way to get a complete coverage across cloud security best practices and compliance controls are through automation. By automating the scanning of your infrastructure as code, you can save time and get coverage, which is essentially not possible with manual work. Examples come in mind, of issues that can be found during this scanning are one, insecure default configuration. For example, if you have a cluster namespace that uses a default name and which is insecure, this is a very common example of common bad practice configuration. Another example can be you're using an S3 bucket that is publicly accessible, and as such, its content can be stolen. This kind of goes back to some of the breaches that we mentioned at the beginning of the webinar. And the third very common example that we're running very often is unencrypted database. So if you're using, the organization is using RDS, that includes sensitive information, and by default, it's unencrypted. So hardening this infrastructure as code configuration based on, best practices can be CIS or other guidelines are mandatory to ensure the use of these best practices and to make sure that your infrastructure as code is properly set. Next slide, please. So one approach was, manually or automatically scanning your infrastructure as code. But as we all know, earlier in the development lifecycle, bugs and misconfiguration are addressed, then the fewer headaches you'll have later on down the line. Identifying, triaging, and fixing issues after they're already being deployed to production is much more expensive, time-consuming, and dangerous than actually uncovering problems in the development phase of your developers. So to effectively enforce policies with your ever-changing infrastructure as code, you need to be able to scan for misconfigurations continuously. And the best way to ensure you're not introducing misconfiguration into these templates is actually enforcing policies on every commit that your developers are doing or every pull request by embedding scanning directly into your code review process. And as you can see here in the diagram that is being presented in this slide, the developer process starts by number one, which is the developer committed a code. And in this stage, you can actually scan this commit and, assuming issues were found, you can share the results through any alerting system that you have, like, Slack, send over email or what have you. And also, if needed, open a Jira ticket or use any other ticketing system that you use for the developer to make sure that he's aware of that and should fix that. The second phase can be not only to alert or to provide visibility to this misconfiguration, but actually block the vulnerable code and protect essentially the main branch. So protect the fact the main branch from integrating to it some code that is misconfigured, which will then right after be deployed into your cloud environment. And the third step as part of this integration into developer workflow is provide a remediation advice and code fixes for rapid mean time to remediate. By providing this remediation advice and actually the code fix, you can help your engineers do that fast and even remove from them the burden of of understanding each and every policy, each and every misconfiguration, and hence also enforce your security best practices. So to summarize, integrating into the developer workflow on a shiftless concept will help you to secure your production environment by identifying this misconfiguration in an early stage. This could be achieved in 3 steps. 1, scan the commit and share results and alerts. 2, block if you think it's worthwhile the code and protect the main branch and so the production. And 3, provide remediation advice and code fixes so your developers can actually fix the issues, fix the misconfiguration, and continue onward with the development and the integration phase. So we talked about misconfiguration, we talked about integrating into developer workflow, but we also know that cloud configuration change all the time. A given web app development constantly introduces configuration changes in order to adapt to new technologies, introduce new features, and meet new requirements. So organizations that are using infrastructure as code, managing and provisioning these changes is more predictable and manageable. However, sometimes, and we see that often coming, this arises certain situations where configuration needs to be changed directly into the production environment, meaning the admin itself goes to the AWS console and make the proper changes. And no matter how tight your infrastructure as code implementation is, out-of-band changes, known also as drift, are inevitable. So simply put, drift is when a configuration changes, and it's no longer identical to the previously populated value, to the one that is actually described in your template. In case of infrastructure as code, drift occurs when a realized configuration differs from the predetermined build time state. So in such cases, there is a reasonably positive chance that security risks are introduced into the environment as a result of drifts in configuration from this security posture. So how do we handle such drift? First of all, by continuously comparing the definitions of the infrastructure as code, what is described in your template, to the actual production configuration, to the actual production environment. Once such once such a case arises when there's a difference between the infrastructure as code definition and the production environment, then we can identify such a drift. And then automatically notifying the teams of the detected drift so it actually can resolve. And notifying through your Slack or through any other means in order to be able to address that and make this drift change as quickly as possible. Now, securing infrastructure as code is not only about the misconfiguration, it's also about monitoring your critical code, your Terraform, your CloudFormation files, or such. So why monitoring your infrastructure as code? Because as mentioned earlier, this is a mission critical asset, and you want to make sure that whatever is deployed in your production environment is actually adhere to the security best practices. Because infrastructure as code changes infrequently, and because unintended infrastructure updates must never essentially occur. So monitoring changes or changes to infrastructure as code should be monitored. For one, make sure that there's inadvertent mistakes. Number two, to make sure that there's no malicious updates by malicious insider or any other way of a hacker that actually coming in, breaching to your environment and making changes that you don't want to be made. And all of these mechanisms of monitoring this critical code, monitoring these files, should be integrated and incorporated to the organization, workflows by simply put using alerting mechanism, whether it's sending that to the application security team through email, through a dedicated Slack channel, or by leveraging any PagerDuty, integration, and probably there are more examples that we could have listed here.
Awesome. Thank you, Amnon. So I guess I'm going to expand upon that ever so slightly, and then we'll gear up for a demo. So one of the core concepts that we want to, kind of espouse is the idea of taking an integrated approach to IAC. So, we just talked an awful lot about IAC scanning. That's great. It helps, find and fix misconfigurations. It's something you can bake into your processes. It's absolutely crucial in terms of being a piece of your IAC security program. However, you can essentially pair that with several adjacent or complementary security approaches to really get a lot more bang out of your buck and to reduce the risk of an overall breach from your IAC. And so to do that, there's essentially another several angles that you can take here. So the first is governance. And what I mean by governance is just, implementing security best practices and security policies in a way that can, essentially reduce risks to your environment. Some of the main things you can do here are things like hardening authentication. So, implementing multi-factor authentication. So here, the goal is to protect against compromised credentials that might be used to adjust your infrastructure as code. Also, enforcing least privilege policies can help to prevent those insider threats. And here, that applies to both malicious insiders as well as compromised insiders. And the idea being that if you limit access to IAC code and IAC templates to only those who need that as part of your job, essentially from the attacker point of view, they have to come and compromise the correct set of credentials to gain access to your IAC templates instead of all of them. So, again, it doesn't solve the problem, but it makes it a little bit better. And as you start to compound several of these approaches, you do reduce the risk of breach. Another one is hard-coded secrets. So, IAC templates can have hard-coded secrets in them. So at the same time that you're scanning for misconfigurations, it can be very beneficial to also scan these same templates for hard-coded secrets because, essentially you don't want to give those secrets over to attackers, right? So they can just kind of walk into your systems. Another one is putting policies in place that prevent and detect code leakage. The tie-in here being essentially that oftentimes IAC templates are kept in the same repos as feature code, and feature code sometimes inadvertently ends up out in public parts of the internet. If that happens with your IAC templates, essentially what you've done is provided a roadmap to an attacker. And if you do have a misconfiguration there, it gives attackers the opportunity to look through the template and find things that might be exploitable. And the last bit comes down to code tampering. So, finding ways to prevent code tampering throughout your software delivery pipelines and processes can be very important. Essentially, you want to prevent insecure IAC from being maliciously deployed via this tampering. So that can be kind of the last piece of the pie. And so essentially by taking these things together, it allows you to take a holistic or risk reduction approach to your IAC security program. With that, I'm going to wrap things up and we'll head into a demo. So, the main takeaways here are essentially that, IAC is the de facto standard for automation in terms of infrastructure provisioning in the cloud. It's important to secure because essentially it amplifies small mistakes across your cloud infrastructure. So again, this one-to-many relationship means that one small mistake can turn into a big attack surface. And then it's important to take an integrated risk reduction approach to dealing with your IAC. It's not just a point solution. It's not just scanning, but, kind of viewing it within the larger, capabilities of your security program can greatly reduce your risk of a breach. So with that, I'll go ahead and stop sharing. And Amnon, you want to give us a demo?
Yep. Let me just share my screen. Can you see my screen well?
Yep, we're loading up right now, and now we can see it.
Great. So essentially, this is the Cycode platform. Cycode is a startup that is aimed to secure, or its mission is to secure the software supply chain from code to cloud. And the way that we do that is by integrating into the different development tools and infrastructure. And as you can see here in the screen, there's a set of different integrations that we're doing around all the most common source controls, builds, container registries, and cloud infrastructure, as well as alerting in order to be able to send what Cyclone finds in the different channels that each our customer is doing. Through this integration with your Git environment as well as the cloud, Cyclone actually is a tool that is built, that is policy-based, policy built, and these policies are out of the box, while we also provide a way to create, for our customers to create its own custom policies. Now, once a violation, once a policy is found as a misconfiguration, then a violation is triggered. And Cyclone provides a long set of hundreds of different policies when it comes to cloud and infrastructure as code. On a side note, I can say that this is not the only use case that we're covering. We're covering much more on that, but the focus will be in this demo for cloud infrastructure as code in the context, obviously, of this webinar. So as you can see here, and again, this is just a demo environment of Cyclone. We provide hundreds of different security infrastructure as code security best practices, which is very much aligned of what we mentioned earlier around template scanning. And so you can then go over and see the different violations that occurs. And we can take just an example here of a specific example that I mentioned earlier in a Kubernetes where there is a default namespace should not be used. So it's not only that once a violation is triggered, then Cyclone shows what is the policy, a quick description, details and where is the violation in a snapshot. But we can also, through Cyclone, you can actually open a pull request from the UI to be able to remediate that. Because as I mentioned earlier, it's not about only identifying and alerting, or it's also about providing the remediation. So through Cyclone UI, you can actually open a pull request and provide a suggested fix for this specific violation. Some of these are very straightforward, and some of these are requiring some, user input. And in the sake of this demo, I won't create the pull request, but wanted to show that in advance. So that was like an example, but not all of that. As you can see, and maybe through the policies itself, you can see here that there's a long set of different policies, not only for AWS, but actually Cyclone address, covers all the leading cloud vendors, which is AWS, GCP, Azure, and Kubernetes, and also all the infrastructure as code providers, Terraform, which is most of you using, but also CloudFormation, ARM for Azure, and YAML for Kubernetes. Now, we talked about reviewing, alerting, and remediating. Another capability that is very important to use, to mention, and one of the strengths of Cyclone is the fact that we don't only support or provide infrastructure as code configuration scanning. What we also do is we are integrating into the developer workflow through a very straightforward configuration, as can be seen here. By toggling, one can actually enable this status check and configure whether he wishes to, fail or not, based on specific thresholds. And you can also run here several settings and configuration, whether you actually not only want to fail the status check if Cyclone found an infrastructure as code misconfiguration, but even block this merge. And if such a setting is being configured, then essentially what happens is that the developer won't be able to merge the pull request because this status check failed, because Cyclone found a misconfiguration. And until this is being resolved and fixed, this code won't be able to merge to the main branch. And I think that on top of that, Cyclone also allows your developer to manage or manage and remediate from within the pull request itself. And all of these violations that I demonstrated earlier can also trigger events and alerts to the variety of these alerting systems that Cycode supports, as well as generate tickets in this set of issue tracking systems that Cycode provides. That was it about the demo. Ryan?
Yeah, all right. Thank you very much. So I think at this point we are ready to open it up for Q&A. So let me share my screen and we'll kick things off. So if you have questions, feel free to put them into the chat box. We've got a couple of them already. So we'll go ahead and answer those questions that have come in the order that they've come in. So the first question, Amnon, I guess this is probably one for you, is what IAC tools and languages do you support?
Yeah, I think that this is very much also aligned with our previous talk. So as was presented in the demo, and we covered that as well. Essentially, Cycode provides or supports, all the common infrastructure tools. All the infrastructure code languages and tools, meaning we support Terraform, CloudFormation, Azure, ARM for Azure DevOps, for Azure, and YAML for Kubernetes. So essentially all the common ones, and we are always welcome to extend that based on customer requesting it.
Okay. The next one here is when finding IAC misconfigurations, sometimes there's a lot of noise or false positives. How do you provide context to reduce this?
Right. So essentially, that's a claim and an issue that we see across the board from different tools on the noise that is being generated because of the long list of policies that is being covered with a lot of violation, and obviously as as your environment grows and as you have probably multi-cloud environment, so essentially the number of results grows even bigger. What Cycode does in order to provide some more context to that is that it doesn't only show the violation, but it also, through its knowledge graph, which is our intellectual property and unique differentiator, through the knowledge graph we can actually see whether this violation is actually then also deployed into the cloud by connecting to the code and to the cloud. And on top of that, we can also map and give context to the specific resource that is being mentioned. So, for example, if we're talking about this S3 bucket, which commit actually set it up, which user committed that, and giving some more context, just on top of the violation that Cycode generates.
Awesome. Okay, so Vladimir asked, do we support TerraGrunt, which I assume is an IAC language?
Yeah, it is. I think my answer is from the top of my head, yes, we do, but it actually requires double checking. So I guess that we can also follow this up offline, Vladimir, but it's a good question, and the answer probably is yes.
Cool. All right, next question. You mentioned integrating into developer workflows. Can you share some best practices based on your experience with customers?
Yes, so we actually kind of touched that in the 3 stages in this specific slide. But what we've learned and saw working tightly with our customers, The first step in order to do that, in order to integrate to the developer workflow, is start small, meaning do not like our customers are not starting to integrate into the developer workflow for all the repositories. They're starting small with just a set of different repos that they want to integrate into as part of the the developer workflow. Once this is being learned by the developers and adopted by developers, then the next step will actually be to increase the coverage to all your repos. So that's like number one. Number two is that where in cases that you have sensitive repositories that hold sensitive information, sensitive applications, what have you, some of our customers actually adopted the blocking mechanism as presented earlier, which means that they're not allowing any code to be merged if it doesn't pass. If the status check is not passed, which means essentially that Cycode did not find any misconfiguration. And the third, which is kind of on top of 1 and 2, is enablement and education for the developers. Obviously, this is kind of integrating into the pull request. It's kind of an intrusive, so to speak, mechanism. And as such, your developer, you don't want to interfere to your ongoing day-to-day development activity. So our customers have built this enablement mechanism, documentation, online sessions, and so forth to make sure that they are aware on Cycode being scanning and the implication of that. So these are, I think, the three main best practices in order to cover that.
Cool. We've got lots more questions, so I'm going to keep them coming. The next two are from Sandro, so I think they're very related, so I'm going to ask them together, and then you can maybe tackle them together. Why do you only refer to cloud? Is your software SaaS only? And then the same question as applies to Kubernetes clusters on-premise.
Sorry,
I guess
can you please?
Is the software SaaS only, or can it also be on-premise? And then
the Cycode one. Yeah.
And then very specifically, does it handle Kubernetes clusters on-premise?
Cool. So the short answer for both questions is yes. Our majority of customers are using Cycode as a SaaS, as a software as a service solution, and connecting, as mentioned, and integrating with their GitHub, what have you, as well as their cloud and other entities or other tools, whether they are on-prem or in the cloud. That said, we also have customers that are very much, not premises and would like to keep, it close to their environment. Hence, want Cycode to be deployed on-prem. And this is another setup, another configuration that we support today, also in a Kubernetes cluster.
Awesome. Sergio asked, can we integrate this tool with Azure CI/CD pipeline?
Yes, definitely you can. We support that integrating. We have several customers that already did that successfully. So we support that as well as any other CI tools that is supported out there.
Cool. That was our last question. Last chance, everybody. If you've got more questions, we're here to answer. I guess primarily Amnon's here to answer, but if you've got questions, we'll give you another 20 or 30 seconds to throw them in the Q&A box. Otherwise, we'll wrap things up.
Awesome.
All right. It looks like that's it. So that was our last slide. I want to thank everybody for their time. And then, I guess back over to you if there's any closing thoughts. Cody.
There absolutely are. So thank you so much, Amnon and Orion. That was an awesome demo and an awesome presentation. I really appreciate the time that went into you guys putting that together. So thank you so much. A quick reminder to today's audience that the session was recorded. Following this webinar, you'll receive an email with a link to access that recording on demand. You can also find the recording living on the Security Boulevard website. Just visit securityboulevard.com/webinars and look in the on-demand section. Now on to our Amazon gift card giveaway. These are for 4 $25 Amazon gift cards. Our first winner is Vinny M. Our second winner is Jane C. Our third winner is Wagner Z. And our fourth winner is Stephen M. So congratulations to the four of you. Keep an eye on your inbox to claim that gift card. And if you don't see an email, just check your spam folder. I would like to thank SciCode for sponsoring today's webinar. I'd like to thank Amnon and Orion for all of their hard work today and prior to today. And I'd also like to thank you, our audience, for being with us for the entirety of today's presentation. This is Cody J. Brown signing off. Have an excellent day, everyone.